Hi, welcome to another episode of Paul Don Power System Design's podcast on the latest in power and power design. I'm your host, Alex Paul, and today I got Chuck Cimino. He's with Keithley Instruments. They're a Tektronix company, and we're going to talk about, well, as we always talk about on this show, energy. Isn't that right, Chuck? Welcome to the show.
For sure, Alex. We'll talk about batteries and energy.
So, on that topic of batteries, what do you see happening in the space right now when it comes to engineers trying to understand more about the batteries that they're specifying?
Okay, good question. So Keithley, as you know, is a precision electronic measurement company. We predominantly focus on DC precision instrumentation. And batteries are mostly a DC device. There are some AC attributes, but in the case of a battery for a smartphone or a laptop or any portable electronics that you described, people tend to do some fairly typical tests, which include charging and discharging the battery repeatedly to evaluate its capacity, its cycle life, its efficiency. People, as you said, people are always trying to get more out of their portable devices these days. And as those portable devices get with larger and larger screens, more power consumption, we see this trend of battery packs and batteries getting larger and larger to sort of still make it through the day like people would like to do, and even beyond with their portable devices. So I would say, you described the trends. People do typically, in the applied areas, people that would sort of design a battery in, they would tend to do kind of the standard testing, which is the cycling, charge and discharge, and then look at capacity over time and compare different battery technologies and options to fit their design requirements. There's this growing area of wearable devices where it's now a much smaller device, but there's still this concern about battery life and efficiency. And again, they're looking at different battery technologies and chemistries to get what they need for their end product.
Got it. Now, how's that really changed at the fundamental design level? I mean, yes, the attention is there, but it's not like they are trying to reinvent the wheel. It's more they're looking for better tools?
Well, if you're talking about in terms of how they do their testing, is that your question?
Right.
Okay. So there's a lot of different ways to do battery cycling, battery cyclic testing. The traditional way would involve power supplies, things like load bank resistors or even active loads, and typically some kind of precision voltage and current meter, perhaps a DMM. And those are good solutions for people who have a fairly good level of expertise at combining test equipment together for the charge and discharge types of studies that people tend to do. What we've been doing, our involvement, obviously we make power supplies and DMMs. We have something called a source meter, or an SMU, that can be used as an active load, but it can also be used as a DMM in a way for voltage and current, and it can be used to charge the battery. So what we typically go to when somebody calls up asking for a battery test solution, we've got a number of app notes we can refer people to, and featured in those app notes tend to be our SMU source meter type products, because they can charge, they can discharge, and they tend to be 5-6 digit precise instruments as well.
Got it. Now, why don't you tell us a little bit about some of the ancillary benefits? I mean, there's no such thing as a tool that does just one job. What are some of the other things you say? You could use it as a DMM as well. What are some of the other things that these devices or this specific product family can do for the design engineer?
Okay, great question. So the source meter SMU instrument was originally intended and designed to test semiconductor devices. I'm sure you're familiar with power transistors or any kind of transistor, or even something as simple as an electronic diode. Transistors and diodes have electrical characteristics typically represented as voltage versus current. You can look at a battery in the same way. A battery is a electrochemical device that produces energy, which represents to the typical application or product that it's put in as a voltage source over time. So we call ourselves the Ohm's Law company in some ways. Volts, ohms, amps is kind of our business, and the source meter really allows you to characterize a very wide range of electronic components, whether it's a battery or a cell, an individual cell, or a passive component like a resistor, or a simple semiconductor like a diode, or even a more complex semiconductor like a transistor, or even an integrated circuit or an amplifier. So really any electronic volt, ohm, amp application that requires precision sourcing and measuring is something you can do with an SMU.
Right. Well, and that's the key, isn't it, Chuck, nowadays? It's about the precision. There's no precision without feedback, and you really rely on these tools to be as accurate as humanly possible, especially when you're designing, and they're measuring now microfarads and counting coulombs. I mean, it's really, really precise work nowadays.
That's right. That's right. And I like the way that you say there's no precision without feedback. A lot of people would like to eliminate test altogether because they view it as a checking step. But if you don't test, how do you know, right? So it's that fortunate catch-22 for us that, scientific method requires an experiment, and then you have to see what happened. And when you go to see what happened in the electrical world, that involves electrical instrumentation, and that precision is important.